Day. I am Engineer Carmel Esberlat, and today our topic is about force system resultant. As you can see, I am using the slides used by Architect Dulutina last semester, but I will record a different video showing, explaining the theories and giving you some examples of this force system resultant na topic. So today we have our objective, and these are the following. The first is to discuss the concept of moment of a force and to show how to calculate in it in 2 or 3 dimensions. Then to provide a method for finding the moment of a force about the specified axis and to define the moment of a couple. Fourth is we will present to you the determining the resultants of non-concurrent force system and to indicate how to reduce a simple distributed load or resultant force having a specified location. So to begin with, we will have to first define what is moment of a force. So when we apply force to a body, it will produce a tendency for the body to rotate about the point, and that is not on the line of action of the force. So this tendency to rotate is sometimes called the torque, but most often it is called the moment of the force or simply the moment. So if you can imagine this situation here, class, you have a wrench and you have a force applied using your hand at the axis at this point O and axis Z. So you have a distance D from the applied force to the point of rotation. So if a force is applied to the handle of the wrench, it will tend to turn the bolt about axis Z at about point O. So the magnitude of the moment is directly proportional to the magnitude of force F and perpendicular distance of the moment arm D. So as you can see here, so the magnitude of the moment is directly proportional to the magnitude of F and perpendicular to the distance moment of D. So if F is applied along the wrench, its moment arm will be 0 since the line of action of F will intersect at point O. So kasabot, no moment if you apply the force in the direction of the axis of moment arm. So if this is your moment arm and your force is also towards or along with this line, so wala moment mahitabo. But if you apply the force at this angle, at angle theta, so you will create a moment at axis Z. So for example, diba? So if this is your if this is your point O and this is your moment arm with a diameter with a length of, let's say, 5 centimeter, and you apply the force here, so there is a tendency that it will turn this way, diba? So mutuyok na siya, and kung mutuyok po na siya dira, so there must be a force or there must be a reaction here nga magpugong sa iyang pag. So we will discuss that later. So magnitude of a moment. The magnitude of moment, MO, where the D is the moment arm. So in our case, the D is the 5 cm or perpendicular. The magnitude of MO with the formula MO is equal to F times D, where D is the moment arm or perpendicular distance from the axis of point O to the line of action of F. So in our previous example sa ato ang ball pen, a highlighter, our D is the distance from point O to our application of load. So in this case, we have 5 centimeter. Units of moment magnitude consist of force times distance. So this is the formula of the moment. M is equals to M sub O is equals to F times D. So the direction of MO is defined by its moment axis, which is perpendicular to the plane that contains the force F and its moment arm D. So rule of thumb Are you familiar with that class? So, rule of thumb, if this is your right hand rule, or this is your right hand, then if the direction of force is going here, counterclockwise, then your thumb is going up, so that will be the direction of your moment. And we will consider this sense as a positive moment. Okay, so again, using your right hand, the direction of the force or the application of the force is going counterclockwise or paana, then up. The sense of rotation, the sense of the moment and direction of the moment will be going up the direction of your thumb. So, mo ni siya dire. Kani mo force counterclockwise, then paana siya. Okay? Do not confuse yourself. Simple lang na siya nga sign of convention of signs. So, resultant. So, at some point, when a particular body is acted upon by different kind of forces, then napo na siya equivalent na summation of moments at a particular point. So, for two-dimensional problems where all the forces lie within the xy plane, resultant moment mr sub o at point O, this is resultant moment at point O, about the z-axis can be determined by finding the algebraic sum of the moments caused by all forces in the system. So, summation of all forces, that is why the title of this topic is Force System Resultant. So, we will find the resultant of all the forces applied. So, again, we can also find the resultant moment all due to the forces applied at a particular point O. So, with our convention, counterclockwise is positive. Summation of resultant moment at point O is equal to the summation of forces multiplied by the distance. So, if using this system of forces, we have F1. Since F1 is producing a moment the direction of the force is counterclockwise, then it is positive. And the moment arm, D1, perpendicular 90 degrees to the point of analysis, point O. 90 degrees na siya. Then, F2 is clockwise. So, that is why it is negative. So, F2 is clockwise. Of course, its moment is also clockwise. So, F2 multiplied by the distance arms, and then F3. So, F3 counterclockwise, the same with F1. So, it is positive because our sign convention tells us that moments counterclockwise are positive. Forces that produces moments that are counterclockwise are positive. So, multiplied with the distance, then you have D3. So, this will be the equation of our system of forces here to get the resultant moment at point O. Okay? So, these are few examples showing how to calculate your forces. So, get your calculator and you can have this as simple as mag-type lang tagpuan, mag-type lang taog. 1, 2, 3. Okay, for our example, we have this different types of fixed supported rod with different applied of loads and the distances. Okay, so for the first example, please get your calculator. Get your calculator, please. And then we will solve this. The first problem is that it is a fixed supported steel rod with at point O. We have to calculate the moment at point O, and then we have an applied load of 100 and a moment arm of a distance from the point of application is So it's as simple as multiplying 100 times the moment arm 2, so you will get 200 Newton meter. So and the direction is clockwise. So this is an isolated point, you don't need to calculate the resultant of this one. So you don't need a sign convention for this one. So you just have to include the direction of the moment, okay? So when you're solving moment problems like this one, an isolated case, you have to specify the direction, okay? And use our sign convention as discussed earlier if it is consists of systems of forces, okay? So B, this is our problem B. You have applied load of 50 Newton and a distance of 0.75. Why 0.75? Because it is the perpendicular distance from point O. So if you will translate move your sorry for my drawing class. So, muna siya yung 50 Newton ng application. So, kung dira ni mo siya i-apply, of course, this distance is 0.75. Right? You will not use 2 because it is not the perpendicular distance from point of application to the point of analysis O. Okay, it is 0.75. So, 50 times 0.75, you will get 37.5 Newton meter clockwise. This one, right? So, the third application, third problem, we have this system here. It's not fixed supported, it is spin and roller here, right? And then you have a load of 40 Newton applied load here, point at the end. So, what will be the moment arm? Before we solve the moment, let's first find the moment arm. So, the moment arm is, we have, if we will translate our moment, our load 40, we will translate at this axis here. So you will get unsa man siya, unsa man nga kuan, diba man siya, since the C here is 2, then you will get 2 cosine 30 degrees and this is 30 degrees. So the moment arm to use is 4 feet plus 2 cosine 30 degrees feet. So this is your equation, and that is equal to 4 plus 2 cosine 30 times 40 pound. So that is equal to 229.28 pound per foot. This one. And it's still clockwise. So, fourth problem, let's solve this here. Let's solve the moment at point O. So, direction is of the applied load 60 pounds dinhi, and its moment arm perpendicular, you have your 1 feet, so opposite, so katawa, right? So opposite, so di kaning previous kay cosine kay adjacent man sa kanang kuan sa arm, then kani so sine, so opposite 45. And so we will have moment arm of 3 plus 1 sine 45 degrees times 60 force. So you will get times 60. So in this case, you will only use 1 sine 45 times 60. So you will get 42.43 pound per foot. Because kanina siya ang perpendicular. The same with this problem, di ba? Naka-angle lang siya. So, sine nangangiyahang kuan. Naka 1 sine 45 degrees because of this angle. And you will translate it here. Muna mo hang load na 60. Then, you will have a distance na gani. Okay, right. So, then, last problem, sample problem, na isolated siya. Okay, you have a moment. I have a load applied here. So, if you will translate that force, na siya din here. So, say yung distance from the point O. Its distance is 4 minus 1. So, very basic lang. 7 times 3. So, you have 21 kilonewton. Take note of the units kilonewton per kilonewton meter. So, that is the force, that is the moment, I mean, at point O. Next, so this is a force system na because we have 1, 2, 3, 4 forces applied on this system, and we are tasked to find the resultant at point O. Here, point O. So determine the resultant force of the 4 forces acting on the rod showing in the figure about point O. So we have to ask summation of all moments at point O. So our sign convention, take note our sign convention, the positive is counterclockwise. So anything na mag-produce of moment that is clockwise, it should be treated as negative. Okay? Do not confuse yourself. This is a system na. So there are many forces applied. So let's start. Summation of forces at point O. So, resultant moment at point O, positive sign convention, positive counterclockwise is equal to the summation of all moments, summation of all forces multiplied by D. Again, summation of all forces multiplied by D. So, we have resultant moment at O is equals to 50. First answer 50. And it is clockwise. So, negative 50 multiplied by 2, moment R, plus the second one, this one, 16 Newton multiplied by its moment R, 0 because it is in line with axis O. So, wala siya. So, may perpendicular distance ano niya? Wala, di ba? Kaya since this one can be translated na mo pass through exactly at point O. Dira, agi siya mismo. So, wala distance. Perpendicular distance. And then, let's consider 20 Newton, this one. So, if this is 3, and this is the opposite, soka, towa, so we will use sine opposite. So, that is why we will use 3 sine 30, and that is the arm. If you will translate this 20 Newton, monisia, diba? So, this distance here is 3 sine 30 degrees. Okay, so this is monisia. And then, counterclockwise because it will rotate here. So, this one will produce a moment na padulong dira. Okay, so 40. Next is the force 40. So, why it is negative? Because this force here will produce a moment that will rotate counterclockwise. Paano siya? I mean clockwise, sorry. Clockwise. And clockwise, for our sign convention, it is negative. So, this is why it is negative. So, the distance here, this distance, if you will translate ganing a force, so this distance here, how much man? So, you have 4 and then the adjacent of 3m, so 3 cosine 30 degrees. So, that is 4 plus 3 cosine 30 degrees, and it is negative. So, you will get your calculator please, 50 times 2 plus 0 because 60 times 0 is 0 plus 20 times 3 sine 30 plus minus di minus 40 times 4 plus 3 cosine 30. Okay, so you will get negative 334 Newton meter. But this negative only shows that our moment is clockwise. So you can use, instead of using negative 34, you will use this sign convention here. So your answer is 334 Newton meter clockwise. That's it. And these are your assignments. Okay? So any questions, you just have to comment in our Facebook or in our, you can chat me at our LMS for this topic. So more examples will come showing your assignments later after a week, then I will show you the results of your assignments, the answer to your assignments. Okay, so God bless everyone. Thank you. Bye.